and pressure inversion all the way up to the top. Does that make sense?
You mean why is it cut off from the bottom up consistently?
Well, why is the whole image dropped, including the top of the mountain? So you'd have to have that inverted gradient from the bottom of the mountain to the top of the mountain and the entire optical corridor for the 150 miles from you to it for you to get that consistent dropping with no distortion.
Oh, so you're wondering why it's happening with no distortion is what your question is, right?
Yeah, consistent drop for the whole mountain, bottom to top, from 150 miles away.
But we do see a consistent drop.
That's my point. So you're saying that the pressure keeps getting higher and higher and higher all the way to the top of a 10,000 foot mountain?
No, I'm saying that the temperature inversion is what is causing that sinking to happen.
Yeah, so you're saying the pressure has to increase all the way to the top of a mountain?
No, because the pressure wouldn't increase with altitude. That doesn't happen. We know that it decreases. I'm just saying that the density increases with altitude because with a decrease in temperature, the molecules are going to be closer together. And that's what density is, mass per unit volume. So when you decrease the proximity, aren't you increasing the density?
So does the density increase all the way to the top of a mountain or not?
Yeah. As far as mass per unit volume is concerned.
Okay, I'd love to see measurements of that.
Yeah, the air at the top of a mountain is less dense than the air at the foot of the mountain.
No, you're equating atmospheric weight to density. Density is not atmospheric weight.
Yes, it is.
If that was the case, why is it that why is it that a bowling ball is more dense than a body of water?
Yeah, but density is the
density is the mass per unit volume, how the molecules
Right.
are arranged in a particular body.
amount of particulates in the volume.
You're cutting in and out. I think your push to talk is you're releasing push to talk too soon. Oh, he's gone. So the air is less dense at the top of a mountain than it is at the foot. Mass per unit volume, there's less of it at the top than at the foot of the mountain.
There's less pressure at the top of the mountain because there's less volume of air pushing down on you. That's why there's less pressure.
Yeah. Well, the air column above you there's less above you. Yes.
Right. So when you're if you measure the pressure at the bottom of a swimming pool, it's going to be higher because you're subject to the entire column of water above you.
Yeah, the weight.
But the surface is going to have less pressure. That's the same with the atmosphere. When you go
Exactly.
higher up,
Exactly.
there's going to be less pressure pushing down on you.
Yeah, I agree with you. There's less weight. Yeah, at the bottom of a swimming pool, there's all the water that is between the bottom and the top is on top of you, right?
Right. But then if you increase your altitude, when you decrease temperature with increased altitude, you're causing the molecules in the atmosphere to move closer together. And isn't that not making the atmosphere denser?
Well, temperature is just the average kinetic energy that the molecules have. There's a relation between temperature and volume and pressure.
There's also a relationship between temperature and density.
Sure. Well, not necessarily.
Not independently of pressure.
I mean, I suppose you could have a closed container and it could start off cold and you could heat it. It would still have the same density, but its temperature would increase. I think. I could be wrong about that. I don't know everything.
You would find the pressure would also increase.
Yeah, the pressure would increase, but would the density increase?
In a contained volume?
Yeah, a perfectly sealed container.
No,
heated.
you got no more mass in that volume by heating it. It's the same density.
Right. The
So density
would
being
stay
a,
the same.
a function of mass and volume, and temperature and pressure being interrelated. So that's why
Well,
you kept saying like, oh, does density when the temperature changes, does the density change? And I say only if the pressure changes.
Woyak will tell you there's always a gradient in there, even in that container.
Very slight.
Usually so small that it would be very difficult to measure, but theoretically measurable.
That would be due to gravity, right?
Theoretically measurable, but not actually measurable.
Well, the actual tools to measure it would have to be very, very finely tuned, depending on how small the volume you're talking about is.
Right. So we've established that the density of the air at the top of a mountain is lower than that at the foot of the mountain. There is a gradient of pressure from sea level up all the way up to the Kármán line and beyond, all the way up to a negative 17 torr. Just before negative 17 torr, the pressure is negative 16 torr, and below that is negative 15 torr, right?
With super dense ether right under the dome. Super dense.
You have to
Evacuated
show that there
ether.
is a dome, Lemon.
We
Or
have
that ether
indirect
can have
evidence.
density, or that ether can be measured or is a thing.
It's
Because
intellectual framework that explains why light appears to be slowed down in the interferometer.
So you said ether has density. Does ether have mass?
Dense ether that is much more concentrated at the top.
Yeah, does ether
It
have
does
mass?
have
How are you
mass.
measuring
The
its
most-
density?
It's more concentrated because it shares less room with matter. Down
More
here, it has to
it's
share
more
room
concentrated
with
in what? How would
matter.
you measure it?
You would measure its indirect effects. You would see if you could accumulate it, like in an Oregon
How would you
generator
measure that
or
you'd
something
accumulated
else.
it?
With the Oregon generator, it looked like it was accumulating something within its confines. You could do
Okay, well,
something similar with
what's the
ether.
units I would measure that in? How would I know I have more?
You could measure the radioactivity, the electrical activity inside the box versus outside.
Okay, so
See if
ether
there's
is
a change from
radioactive?
free space. In the Oregon generator, they measured some sort of electrical radioactive difference inside the box versus outside. Something
So I
being
could, like with a
accumulated
Geiger
from free
counter,
space.
perhaps I could measure the amount of ether I have around me?
Might be one tool of many. After you accumulate it in a vacuum or whatever.
Okay, so I need a vacuum and a Geiger counter, and then I can count ether.
And you can count its indirect effects. There's many ways to do a possible experiment.
How would I
Accumulate
measure
it,
its indirect? I
measure
need
inside.
something I can measure. I need to be able to measure what this is, and so I know how much it's affecting everything.
Measure the rate of light's travel through it.
Listen,
The
you
rate
could
of light
you could just
traveling
measure.
against it versus
So,
light
if I
traveling
measure
with
the
its
speed
flow.
of light in a vacuum, that tells me how much ether is in that vacuum.
You could just measure
may
it.
tell you
Hey,
indirectly how the light is traveling through the ether, giving you an indirect
So-
indicator.
So
You
if I
could
make
also
two,
possibly
if I
measure
make
its
two
viscosity
vacuum
like Yuri
tubes,
Galayev did.
if
So
I make two
then
vacuum
you could
tubes and I measure the speed of
viscosity
light
the
through both of
ether.
those vacuum tubes, Lemon, then I will be able to tell which tube has more ether in it.
you could just
You
measure
have
it.
everything that you need. Accumulate it, see how stuff travels through it, measure the conditions inside and outside the accumulator, electrical energy.
So you're saying no, I
discharge,
can't measure it
etc.,
by the speed of
etc.
light. The answer is no, I can't
You
measure it
have
by the speed of
everything
light.
that
How
you
can I
need.
measure it?
You can measure it. I'll tell you how you can measure it. You can measure it theoretically. Just like
You
you
can
said,
measure
we're
it
going to measure the
theoretically, Jeremy.
gradient.
Okay, good.
theoretically, yeah.
You
It
wonderful.
appears to have
What's the units
physical
of theoretically?
The same units we're using when we're going to measure it theoretically, measure the gradient in that container.
But it appears to have physical effects. Light
When
appears
I
to
said you can
flow
theoretically
against its
measure it,
flow.
Jeremy, what I mean is, so you normally measure things with a 12-inch ruler, right? Like, or maybe a measuring tape with inch gradients on it, right? Jeremy, you'd agree with that?
Yeah, that's fine.
Okay, so normally, for normal measurements every day, you just measure stuff with a 12-inch ruler. That gives a pretty good measurement. So say we measure with 12-inch ruler, and then I say, okay, I'm going to give you 100 flies. Now, theoretically, flies have wings that are slightly different from each other. Would you agree with that?
Yeah.
Okay, so since the wings are slightly different, we could say probably the wings are very slightly different thickness. So now I'm going to give you a 12-inch ruler and say measure the wings of 1,000 flies. And we know, because everything, every living thing is slightly different than every other living, there's very tiny variations, even in things that are almost identical. And we could say the fly's wing thickness is different. But if you have a 12-inch ruler, there's no way you can give me an accurate measurement of how thick the wings flies are. The fly's wings are.
I could give you an accurate measurement theoretically.
Yeah, I mean, not with that tool. If you had a different tool, if you had a different tool, you could give me a measurement. So when you only have a tool to measure it that's not good enough, you could say theoretically I could give you that measurement, but I would need a different tool.
No, I could theoretically probably do it with a ruler.
No, you couldn't. I know for a fact you could not give me an accurate measurement of a fly's wing with a ruler. You just couldn't do it.
Theoretically, I could do it.
No, not with that tool. That tool is completely incapable of giving you an accurate measurement. You, as a person, could theoretically give me that measurement, but not with that tool.
I don't want to hijack your whole conversation. Go ahead.
No, I think this is an important thing to clarify, because you're jumping on the fact that I said you could theoretically measure something. You would need an appropriate tool to make that measurement. That's why I said theoretically. I don't know what the appropriate tool is. It would have to be incredibly sensitive.
Well, the first step in any measurement is noting a difference. That's the first step, a difference of something. The second step is finding something that is regular enough to note that difference. A ruler that is, the length that you're trying to measure or within the bounds of that measurement. Something that can accumulate the difference. Something like light fringes in the interferometer experiment that seem to show a difference of the light going in this direction in space versus this direction in space, showing some sort of solidity to space that's slowing up the light. Stuff like that.
The problem I have, Lemon, is you make all these claims about the density of ether and where the ether is and what the ether is affecting, but you don't have any way to measure this ether you're talking about. You just say ether, and then you go, and I go, okay, well, how much ether is there? Oh, I don't know how much ether. Okay, well, how would I tell how much ether? Oh, I don't know. You'd measure the speed of light, and I go, okay, I'll measure the speed of light. And you go, no, don't measure the speed of light. Measure the radioactivity. Well, okay, I'll measure the radioactivity. No, don't measure the radioactivity.
Trying to figure out the viscosity of the ether. So there's different ways that we can go with this.
Now you want the viscosity. We can't even tell if it's there. We can't tell how much is there. Now you want to measure the viscosity of it?
There's something flowing up the light. What are you talking about? There's something flowing up the light in the interferometer. Some solidity to space.
There's something slowing the light. But you can't measure it, quantify it, touch it, make it tangible, manipulate it in any way. It just magically shows up.
Experiments of Dayton Miller and others, the Oregon experiments of Wilhelm Reich, so you can get a running idea of how to approach it. I shouldn't have to do the thinking for you. If you're
but it doesn't have any way to measure it. It doesn't have any tangible effects that we can quantify.
Look at Reichenbacher and other people who tried to measure free energy from space. Look at the Casimir effect. Look at the 0-point energy field. Come up with something.
You come up with something. All you're doing is saying ether has density and viscosity by the dome, but you have nothing to give me for it.
You need to get a different perspective anyway. So I point you in the right direction.
You're the one making the claim. You have to provide the proof to your claim. We don't have to provide the proof to your claim.
He's gone. He left. He wanted to gish gallop and leave. It's typical Lemon.